forever, never touch, right? You've learned about parallel lines before. You should be familiar with them. Perpendicular lines, you should also be familiar with. There are two lines that form a 90-degree angle. Okay? So we are going to look at those today. So what I want you to do first, these first several slides are ones that I just want you to graph for me. Okay? So it's got two lines. So we'll do the first one together, but then I'm just going to let you do the others yourself, because hopefully you know how to graph a line. If not, we will work on it. We're just going to graph both of these lines. So we've got y equals 2/3 x minus 4. So Olivia, what is the y-intercept of that top line there? It is -4, so we put us a dot right there on -4. And Olivia, what's the slope? Okay, so that from here, that means I go up to the right here. Parallel, perpendicular, neither. Perpendicular. And mathematicians do not like to write long words like perpendicular because they avoid words at all costs sometimes. So perpendicular, they created this symbol right here that looks like an upside down capital T. That means perpendicular. So if you want to write that, it is a mathematical symbol that means perpendicular, and you don't have to write the word. You could just do that. It'd be even easier. Okay? All right. Okay. All right. Okay? For example 4, you have to solve those for y first. Cannot graph them till they're solved for y. So you had 2x plus 3y equals 9. So you subtract the 2x. You divide by 3. You should get y equals 3 minus 2/3 x, or you might write it with the x first. That's fine. But you have a y-intercept of 3, a slope of -2/3 for that first line. And then for the second one, you've got 3x minus 2y equals 10. So you subtract your 3x. You divide by -2. You end up with -5 plus 3/2 x. So you should have a y-intercept at -5 and a slope of up 3 right 2. What? You've got to divide by -2 right here whenever you are getting rid of that 2y. So 10 divided by -2 is going to be -5. For the slope, the negatives cancel and it becomes positive, but for the y-intercept it does not, unless I copied something on it. Let me see, because it'll be negative. Okay, parallel, perpendicular, neither. Perpendicular. Perpendicular. You got a right angle there. Okay. All right, example 5. Okay. So whenever you solve these, the first one, you got to move the 4x over, divide by -3. You should get y equals -4 plus 4/3 x. There is. It is just two lines next to each other, like that. That's a sign for parallel, but I don't think we need it on this one. Okay, so for this one, and let me use like a straight line here, because let me fix this where we can use a straight line. That'll be a little bit better to see. So you have this line right here, and then we've got, let's see here, this line right here. Let's extend it on out. Okay, so these two lines, you should get y equals -4 plus 4/3 x, and then you should also get y equals 2 minus 3/2 x. Okay, these two lines, they do not touch. What am I wrong about? I didn't say they were parallel. Oh, okay, you're right. It should be a negative. Let me change that. Even though this is an important point. This is an important point. these aren't parallel anyway. So I did mess up, but it is actually almost a good mess up because this is confusing to kids sometimes. These kind of look parallel. If let's say they were the right ones, I'll fix it here in just a second. They kind of look parallel, but if you draw them on out and you draw them perfectly straight, are they the same distance apart down here as they are up here? Are they eventually going to cross? They are way down here off the screen somewhere. They are eventually going to cross. So are these lines parallel? They are not parallel, even if they were like they're supposed to be. But I did graph it wrong, so I'm going to fix that here in a second. So now that sort of leads us into what we're going to do. We really need a better way to tell if they're parallel or perpendicular other than just looking at it. Because, you know, depending on how well you graph that, they might look pretty parallel on that one. But let me fix that one because you're correct. I did mess it up. I did not do the negative slope on the green line. So let me fix that to negative 3 over 2. Negative 3 over 2. Okay, parallel, perpendicular, neither. These are neither. That angle right there is not really a right angle, but it looks kind of close, which tells us we need a better way, which we're going to learn here in just a minute. Question, Aiden? Okay. Go ahead. No. Well, you mean if you graphed it wrong, but then had the wrong word, so you ended up being wrong twice, which made you right? No, I'd still take off. Okay. All right. Now, number 6, I had a lot of you asking me about number 6 because you got 8 minus x equals y. This one is already solved for y. Y is already by itself. It's just they wrote the y on the end, which is weird. They don't usually do that. But we could move the y over to this side and just make it y equals 8 minus x or y equals negative x plus 8, whichever way you want to think of it. You have a y-intercept at 8 and a slope of negative 1 for the green line. And then you do have to solve for y for the second one. So you would subtract x. Y would equal 4 minus x. So that would be this blue line here. Okay. Parallel, perpendicular, or neither? Parallel. So parallel, or Julie asked a minute ago about the symbol. 2 lines just straight together, looks like 2 L's next to each other. That also means parallel, so if you write me that symbol right there, you don't have to write the word parallel. Okay? For 7, you are going to solve the first one. You get y equals 9 minus 3x. And that looks like this blue line right here. And then for the second one, you're going to get y equals negative 1/3 x minus 2. That is the green line here. Parallel, perpendicular, or neither? They do cross, but do they make a right angle? Is this one a right angle? It's not. So this is neither. Sorry, there is no symbol for neither. You'll have to write that word out. No, it will not be. It will not be accepted mathematically. So whenever you move on to other classes or college or things like that, and you're still using your symbol that we just made up here, it won't be good. So let's just write the word. Okay. All right. Example 8. Y equals 9 is just a horizontal line at 9. The second one was throwing a lot of you guys off. You got to get every time you graph anything, unless it's an x equals a number line, you got to solve for y. So you got to subtract the 2 from both sides, and it gives you y equals negative 2, which is a horizontal line at negative 2. Are these parallel, perpendicular, or neither? They are parallel. Questions? Yes. You gotta get the y by itself. It's always gotta be by itself before you can graph. Okay? Alright, so I want us to look back through because on your next slide you've got some blanks we need to fill in here. And let's look at all of the ones that were parallel. Let's see what. Okay? Parallel. So, parallel lines, and my lines went away here. But, what was the equation for example 2? Y equals, it's on your paper. Okay, and what's the other one? Okay, so if we look at the slope of both of these lines here, we had 1/3 here, we had 1/3 here, they were parallel. Okay, those weren't parallel. Where's another? These were parallel. I had a slope right here of -1, a slope right here of -1. They were parallel. This last one, what was, I can't highlight the slope here. What was the slope for this line? Zero. And slope here is also 0. Okay? Okay? So, whenever we see the slope is the same, those lines are parallel. So, like back, I know I graphed it wrong, but back whenever I had a slope of 4/3 and I thought it was positive 3/2 because I graphed it wrong, I couldn't really tell if those were parallel or parallel or not. I would know they're not parallel because they don't have the same slope. And that kind of makes sense because if two lines are never, ever, ever going to touch, they got to be the same distance apart. If they're closer on one end, eventually they're going to cross, right? So, so on that slide right here, parallel lines have equal slopes, or you could say the same. Now, you must have the line solved for y first to be able to tell that. If it's not solved for y, just like you can't graph it if it's not solved for y, you don't know what the slope is if it's not solved for y. So the line must be solved for y first. Perpendicular lines are a little bit trickier though. Okay? So everybody make sure you've got that written down. Parallel lines have equal or the same slopes. Okay? Let's go back and look at our perpendicular lines. So our first one was perpendicular. What were the equations since they disappeared on me for the very first one? What? Plus 3, plus 1. This was a -4. Okay. All right, so if we look at our slopes here, we'll highlight our slopes. So I've got 2/3 and -3/2. Those lines were perpendicular. Let's look at our other ones. Oh, you're going to tell me this one too. I don't know what this is doing. What were the equations for? Well, I can tell you. I can just do it. Look, y equals -1/2 x is one of them. And y equals 3. What, I have 2x. Let's put x first. 2x minus 3. Okay? So, here, slope is -1/2. Here, slope is 2. Okay? These were perpendicular. I had a slope of -2/3 and +3/2. These were neither one, so that does not interest me. Parallel. These were neither one, so that does not interest me. So if I look at those three that were perpendicular, I had -2/3 and 3/2. I had negative 1/2 and 2. I had 2/3 and negative 3/2. What can you guys tell me about the slopes of perpendicular lines? Okay, they're definitely different, but just being different doesn't make them perpendicular, because over here, where I had these that were neither, I had a slope of negative 3 and negative 1/3, and they were different, but they weren't perpendicular. But they won't, you definitely are going to have different slopes. What else do I have? What else do you notice? Okay, one has to be negative, one has to be positive. They have to have opposite signs. That definitely has to happen. Okay? Because if you have a decreasing line, you have to have an increasing line for it to be perpendicular to it. So they have to have opposite signs. What else? Something more specific. Notice here I had 2/3 and I had 3/2.
They're opposite, like they switch.
Okay? Did that happen on this one? It did. It doesn't look like it did as much, but this would be 2/1. Right? So I had 1/2 and 2/1. They flipped upside down. Right? Over here I had 2/3 and 3/2. Okay? So, and if you think about this, this kind of makes sense. If you go down 2, right 3, well, the opposite of that would be up 3, right 2. It's sort of the, opposite of what we've got. So, we're going to use some fancy words for this. So, make sure you're over here on the slide that says conclusions. Okay? We're going to use one word that's not so fancy and then one that's very fancy. You might know it. We'll see if you can. So, I said the first thing we said is that they have to have opposite signs. So, we will say perpendicular lines have slopes that are opposite. And then anybody know a fancy word for flipping a fraction? Oh, good. Reciprocal. So, reciprocals. Sometimes I do, but not for this. Yeah, she is. Definitely. If something like patty paper can make you whine, then...
What other word is another word?
I've noticed. Alright, so opposite means change the sign. And reciprocals means to flip. So flip and change the sign is what you need for perpendicular. Okay? You need to know that word reciprocal, because you could have a question on a test or a quiz or the final exam on Math 1 that might not even really give you a problem. It might be like sort of a fill in the blank, like perpendicular lines have slopes that are blank, and one of the options is opposite reciprocal. So you need to know what the word means, reciprocal. But as far as writing it down, we're not going to actually write it very much. We just need to know what it means. So now notice these two lines, right? Oh no, not those two. Where were they? These two lines, the ones I graphed wrong the first time. These two lines, they were kind of close to looking like they were perpendicular, right? If you had said these two were perpendicular before I taught you anything, I would not be, too upset with you, because that would be a fairly logical conclusion. But now that we know that slopes have to be opposite reciprocals if they are going to be parallel, if we look at our slopes, I had 4/3 here and negative 3/2 here. So I would know automatically those cannot be reciprocals, because they're not, those cannot be perpendicular, because the slopes are not opposite reciprocals. They're opposite, but they're not reciprocals for that one. Okay? Alright, so let's look at, so one of the types of questions you're going to have is it's going to give you two lines, and it's going to ask you if they're parallel, perpendicular, or neither. Solve the equations for y if you need to. Look at the slopes. Tell if they're the same or if they're opposite reciprocals. Here are some of the other types of questions we're going to have. And I'm giving you several, and you're going to have to tell me what, we're going to have to put those, I don't know why, I guess it's because I had copied and pasted something in that it's now not recognizing that my equations have disappeared. Alright, so, let me go back to page 4. Alright, so number 9 says find the slope of the line that is parallel to y equals 3x minus 4. So Cole, what is the slope of the line that's parallel to y equals 3x minus 4? It is not. What is the slope of this line? That's the y-intercept. 3. Just the 3. When we talk about a slope, we don't put the x with it. Okay? So it would just be 3. Because the slope of this line is 3, so the slope of a line parallel to it is 3. I've just thought of a technicality I need to tell you. A technicality. It doesn't happen often, but it does sometimes happen. Parallel lines have equal slopes, but different y-intercepts. Add that in to that slide right there. They have equal slopes, but they have to have different y-intercepts. Why? If not, it's the exact same line. Sometimes the word they use for that, if you get the same line, sometimes they'll use the word coincide. The lines coincide; they're the same thing. So they have to have different y-intercepts. But this just says the slope of the line that's parallel. It's only asking about slope. Okay. So, Aiden, we're going to find the slope of the line that's perpendicular to y equals 3x minus 4. So what would the slope of the line perpendicular to y equals 3x minus 4 be? Okay. What is the slope of this line? 3. Okay, so perpendicular and parallel has almost nothing to do with the y-intercept. Except for if they're parallel, they can't have the same y-intercept because they're the same line. So we're pretty much not going to look at the y-intercept when we're talking about parallel and perpendicular. We're mostly looking at the slope. So the slope of this line is 3. I'm going to make it 3 over 1. Okay? Because for perpendicular, our slopes are opposite reciprocal. So we got to flip it and change the sign. So if it's not a fraction, go ahead and make it a fraction by putting it over 1. And then to get the slope, we have to have the reciprocal, which means we're going to flip it and make it 1 over 3. And we have to have opposite signs. So since this is positive, we need a negative. So we'll have negative 1 over 3. Okay? Questions? All right, let's see. This one had y equals 1/2 x minus 4 that disappeared for me somehow. Okay, so we got to find the slope of the line that's parallel to y equals 1/2 x minus 4. So, Dylan, whenever we look at this one right here, we're looking for the slope that's parallel to the line y equals 1/2 x minus 4. So before you can answer these questions at all, you got to know the slope of y equals 1/2 x minus 4. So what is the slope of y equals 1/2 x minus 4? Okay? Slope is your number next to your x. Okay? The one right in front of your x. So that's going to be the 1/2, right? The one that's multiplied by your x. So the slope of this line is 1/2. What do we know about parallel slopes? So what do we just write down? Okay? They're equal to each other, right? So if we answer this question, then find the slope of the line that's parallel to y equals 1/2. What is our slope going to be? Okay? Dylan? 1/2. Yeah. Sorry. Okay? Alright, so the slopes are just the same. So asking this question, what's the slope of the line that's parallel to this line, is really just saying what's the slope of this line, right? Because parallel lines have the same slope. Okay? And then example 12 has that same line, y equals 1/2 x minus 4. Okay? So, for this one, Julie, I already heard the answer. What is it? It is negative 2. Because the slope of this line is 1/2. So you've got to flip it, which means it's 2 over 1. And you got to make it, change its sign. You got to make it negative. But we don't want to write 2 over 1, really, because it makes it, we look like we don't know what we're doing. But Julie knew what she was doing because she gave me just negative 2 right away. Okay, Questions? Okay. All right, let's continue. I bet I won't have these either. Okay. All right. Y equals 8x minus 4 and negative 8x plus y equals 1. All right, so the first, this one asks us parallel, perpendicular, neither. Let's do this without graphing. We graphed the first ones, but let's do this without graphing. So the slope is what we're worried about. Slope of this first line is 8. That one's already solved for y. Okay. Evan, how am I going to find the slope of the second line? Okay, and when I do that, what do I have to do with it? Add the 8x. Alright, so y equals 8x plus 1, or you can write it 1 plus 8x. It does not matter. What's the slope of that line, Evan? It is positive 8. So are these lines parallel, perpendicular, or neither, Evan? They are parallel, so you can just put those two lines right there. That means parallel. Or you could circle parallel, or you can write the word parallel. The only thing I will warn you about is if you're using the symbols for parallel and perpendicular, make sure it's obvious that's your answer and not just like, don't do this, like you just wrote an 11 over here next to your paper. Circle it or do something so I don't miss it there, okay? All right, questions on 13? All right, let's look at 14. Oh, wait, 14's on the same page. I just got to scroll down. Okay, so 14 has 2x minus 5y equals 10, and I'm going to write this one here. Y equals 2 fifths x minus 2. I don't know why all those went away. All right, so the second one we can already find the slope of. So, Olivia, what's the slope of that second line? The y equals 2 fifths x minus 2. 2 over 5, perfect. So we've got 2 over 5 for that slope. We don't have the slope for the other one. So Gabe, what would I do to find the slope for that first line? Good, I'll subtract 2x. So negative 5y equals negative 2x plus 10. All right, what would I do next, Gabe? Almost. What kind of 5 should I divide by? Negative 5. Okay? All right, so y equals, and then what's negative 2 divided by negative 5, Gabe? Very good. So I'll have 2 over 5x, and then 10 divided by negative 5, negative 2. Okay? So, we got something here. We got slope of 2 fifths. Parallel, perpendicular, neither. This one's got a trick to it. They look parallel. Are they parallel? Why are they not parallel, Evan? They have the same y-intercept. So you would say for this one, neither. And another word that sometimes you will see, like worksheets or problems use, is coincide. Let's write it down so we know what it means. Coincide means the same line. Coincide. Okay? All right. Let's continue. Okay. So, problems like 15, students often think are very difficult because they have a lot of words, but this one is a very simple problem. Okay? So, write the equation of a line that is parallel to y equals 3x minus 4 and has a y-intercept of 8. Okay? So, Monica, what would the answer to that be? A equation that has equation of a line that is parallel to y equals 3x minus 4 and has a y-intercept of 8. It's an easy, easy problem. What two things do you need to know to write an equation of a line? Slope and y-intercept. So, they told me the y-intercept is 8 here, right? So I'm going to have y equals plus 8 over here on the end. And I know it's parallel, the line's parallel to y equals 3x minus 4. So, what is the slope of the line going to be? 3, right? So we'll have 3x plus 8. Y equals 3x plus 8. So if you get a problem like 15 that tells you the y-intercept, it's a pretty easy problem. You just got to read through and look for what they're giving you because you got to have slope and y-intercept. Now, 16 is not as easy. Because do they give you the y-intercept on 16? They do not. Okay, 16 says write the equation of a line that is parallel to y equals 2x minus 1 and passes through negative 3, 1. So, this one's not as easy because they don't give you the y-intercept. But, do they give you the slope? Pretty much. What is the slope, Aiden? 16. Okay, slopes don't have x's with them, but the slope is 2, right? So, yep, so it'll be 2. Because the slope tells you rise over run, and you can't go up 2x. Because what does that mean to go up 2x, right? You don't really know what x is. 2x over 1. So the number only is the slope. But the slope is 2, so we know our slope is 2. So we know in y equals mx plus b, y equals 2x plus b. Okay. I'm not sure. I'm not there yet. So what did you do to get 7, Jesus?
I did 1 equals 2 parentheses.
Okay. Very good. These are just like those other problems that we were doing. So we know it passes through these points, and that's an x-coordinate and a y-coordinate. So we put our x right here, and we put our y right here. And we're just going to plug that in and solve for the b, like we did on several of the other problems that we did. So 1 equals negative 6 plus b. How do I get that b by itself? Add that 6. And so I get 7 for my b. But the question said write the equation. So my answer is not 7. What's my answer?
Y equals 2x plus 7.
Very good. 2x plus 7. Okay. Okay. Questions? Okay. Look at 17. 17. Let me put my line back here. It disappeared on me. Y equals 2/3 x minus 4. Okay. I want the equation of a line that's parallel to y equals 2/3 x minus 4 passes through 6, negative 9. So, they did not give us the slope or the y-intercept, but the slope should be very simple to find. What's the slope of this line, Adam? Very good. So, slope is 2/3. So, we're going to use y equals mx plus b. So, y will equal 2/3 x plus b. What do we do now, Adam? Okay, you were not paying any attention to the last problem, obviously. Okay? I promise you guys, you are not going to learn this on your own. Well, maybe there's some of you. Maybe you could. But probably most of you are not just going to like automatically know how to do this. So pay attention. And then you will learn how to do it. And then you can do it. And it's really not all that bad. So, this is an x-coordinate. This is a y-coordinate. Okay? So, we're going to put 6 and negative 9 into this equation. So, for the y, we're going to write negative 9 equals 2/3. 2/3. For the x, what do we put, Adam? 6. And plus b, because that's what we're trying to find. We need our y-intercept, right? So this plus b, that b right there, that's what we're trying to solve for. Okay? So, don't have a panic attack. What have we got to do? 2/3 times 6.
I'll put a 1
2/3 times 6 over 1, 12 over 3, 4. Okay? So, -9 equals 4 plus b. All right, what do you do, Adam? Got to get that b right there by itself. Okay? So subtract that 4. So you get -13 equals your b. So there's your y-intercept. Okay? So you got a slope of positive 2/3 and a y-intercept of -13. So tell me the equation of the line, Adam. Y equals... Perfect. All right, questions? All right, we just got 3 more to go. We're almost there. Okay, 18 says write the equation of a line that is perpendicular to y equals -3x plus 2 and has a y-intercept of -5. Okay, so Madison, for this one, they gave me the y-intercept, which makes it easy. I just know I'm going to have y equals, and I'm going to have -5 over here on the end as my y-intercept. They did not give me the slope, but I can find the slope. What is the slope for this going to be if it's perpendicular to y equals -3x plus 2? Okay, 1/3. So we'll have y equals 1/3 x minus 5. Okay, because we know right here that's 3 over 1. To have a perpendicular slope, we've got to flip it and change the sign. So where it was negative, we've got to make it positive. So our equation is y equals 1/3 x minus 5. So no, if it gives you the y-intercept, that makes the problem a lot easier. You don't have to solve nearly as much. Okay, 19 and 20 are more difficult. So this gives you y equals 1/2 x minus 1. Okay, and one of the big things that's a lot of times difficult for students is remembering parallel and perpendicular. A lot of times you get them mixed up, so I always underline or put a box around star that word, parallel or perpendicular. So write the equation of a line that is perpendicular to y equals 2x minus 1. So the slope of this line, okay, Malia, what's the slope of this line? It's 1/2. So what is the perpendicular slope, the one we need to use? -2. Very good. We're going to flip it, make it 2 over 1, make it negative. So -2 is your slope. So we've got y equals -2x plus b. Okay? After this, it's that same thing we've been doing. So, Aiden, tell me how to do it. We got to solve for the b. So what we got to do first? Right now I've just got y equals -2x plus b. I can't solve it with the x's and y's. Okay, let's plug in. So what do I plug in for y? And what do I plug in for x? There's your x. There's your y. -3 plus b. So I get 1 equals, that's going to be +6 plus b. And then what do? I subtract that 6, so I get -5 equals b. What's the equation of the line? Perfect. Good job. Okay. Okay. Questions? Okay. 20 says write the equation of a line that is perpendicular to 2x minus 3y equals 9 and passes through -8, 4. This is almost the most difficult question you're going to have. Sometimes they go crazy and really ask some crazy stuff on the exam, but this is pretty much the most difficult question you're going to have. Other than that, it'll be a bonus question if it's more difficult for me. Alright, so I've got an equation. It's perpendicular to this one, but it passes through -8, 4. So I need to know the slope. You always need to know the slope first. But can I find the slope of this line as it is? I cannot. So Riley, what have I got to do to find the slope of that line? Very good. So -3y will equal, make sure you got a -2x and then plus 9. Or you could write it 9 minus 2x. Okay? Alright. So, Riley, after that, what are we going to do? Okay, what kind of 3? It's going to be negative. So when you're dividing, you don't change the sign. It's when you're adding or subtracting that you use the opposite sign, but when you're dividing, you do not change the sign. Okay? So y equals, Riley, what's -2 divided by -3? Very good. Positive 2/3 x. What is 9 divided by -3? Very good. -3. Okay. Now, here's what's tricky. You do all that, you feel like you're done. Are we done? No. We haven't even found the first piece of the other line yet. So, the slope of this line right here is 2/3. And so the slope that we need to use, our slope, our perpendicular slope, is going to be 3/2, except for it's going to be negative. Okay? So that's going to be y equals -3/2x plus b. Here's what throws a lot of kids for a loop. You're not going to use this y-intercept at all. You don't need it. Okay, so it, you find it whenever you solve for y, but you don't actually use it for anything. Okay? So, Aiden, what do we do now? Good. So we'll have -3 halves times -8. Good. And then for our y, 4 equals -3 halves times 8, and then we'll put our plus b over here because that's what we're solving for. -3 halves times -8. Yeah. We'll do 8/1. Give them a chance. Don't holler it out. Okay? What do we do to multiply fractions? Good. And what will we get? Over. Very good. And 24 divided by 2 is 12. Good. All right, so 4 equals 12 plus b. All right, keep going. What do I do next? Is 12 multiplied by the b? Subtract. Okay. All right, 4 minus 12, what do we get, Aiden? What kind of 8? So -8 equals b. So finally, we've got a slope and a y-intercept. So Aiden, what's the equation? Y equals? Careful. If I write that, it's not really an equation of a line because it doesn't have an x. Got to put an x right here beside of that. Okay? All right, questions.